Okay, so here we are. This is section 5.5. Problem number 1 there. So let me just rewrite that for you where we have a little more room. 4/5 plus 1/8. So 5, number 1. All right, 4/5 plus 1/8 is Q over 20. Okay, so we're supposed to solve that problem for Q. So this whole chapter is about fractions. This is, they call it rational expressions, rational ratio fraction. It's a fancy way to say fractions. So this whole chapter is messy. It's all about fractions. So what do you do when you have fractions? Now, in the last section, the one you just did for homework in 5.2, we, well, I don't want to confuse you. Yep. Never mind. Let's just go for it. I was going to compare, but let's just move forward, and I'll compare on practice exam day. That'll be better for you. Let's just move forward. Basically, you have to look at the 5, the 8, and the 20, and you have to find a common denominator for 5, 8, and 20. Remember how to do that for 5, 8, and 20? Yeah, you put them in the box. Yeah, remember the box thing? We put the 5, 8, and 20 in the box. Anybody just know off the top of their head what 5, 8, and 20 all go into? 40. If you know it's 40, great. Just write it down and go. But let's suppose we don't know that, and let's just go forward. So how do you do the box thing? What do you do? Yeah. What goes into 2? Now, you can just do 2 numbers at a time, huh? So what goes into 2 of those numbers?
5.
Yeah, 5 goes into 5 and 20. Or you could do like 4. 4 goes into 8 and 20. Either one. Start either way you want. I'll just do the 5. Sounds good. So 5 goes into 5. I'll just divide this one by 5, and I'll divide this one by 5. But the 8, I can't divide by 5, huh? 5 doesn't go evenly into 8. So it leaves a 1, leaves a 4. What do you do with the 8 then? Just bring it down. Is that good so far? I just divided both those by 5. Okay, now what goes into 1, 8, and 4? What goes into at least 2 of them anyway? 4. So we'll do 4. So I'll do that next. So divide by 4, divide by 4. I put a 4 out here. And so that leaves a 2 and a 1, and then just bring down that 1, huh? And we're done there. How do we know we're done there? Well, because nothing else divides by 1, 2, and 1. You may think 1, yeah, well, 1 divides by everything. We're not doing 1. We're not counting 1. We know 1 goes into everything. So no other number other than 1 divides into 2 of them, right? Nothing else. So you're done. Okay, great, I'm done, but where's my answer? Yeah, remember we multiply all these numbers on the outside. Times, 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 times. Comes out 40. There's the LCM, LCD, whatever you want to call it. Same thing. 40. And we good so far with all of that? Whoops. So the LCD is 40. So now, what do we do with that LCD? Well, here's what we're going to do. Now, this is different than last section. It's actually easier. Because we have an equal sign, right? That's what's different in this section compared to 5.2. There were not. This is what the last section like. There'd be like a plus sign there. There'd be no equals. What's different in this section is we have equals. That's nice. They're going to be easier. When you have equals, that means you have a left side and a right side that are equal, that are in balance, huh? They're equal to each other. And so when the two sides are in balance, what you want to do is make sure you do the same thing to both sides. You can do anything you want. You can multiply by a million if you want to, as long as you do it on the left side, all the terms on the left, all the terms on the right. It'll be okay. We're not going to multiply by a million, but we're going to multiply by 40, aren't we? 40. Only the top, by the way. That's what probably will seem different than the last section. I'm not doing top and bottom. No more of that top and bottom stuff. Why not? Because I have an equal sign. When you have an equal sign, you're not thinking top, bottom. You're thinking left, right. The left equals the right. The left and the right are equal. They're in balance. So all of my thinking is left, right. So you might notice in math, so I guess I am doing a little bit of tying it to the last section. I'll talk more about this on practice exam day. But in math, we're always keeping the balance. There's 2 ways to do that. Top, bottom, or right, left. Top, bottom, or right, left. In the last section, we did saying top and bottom, huh? That was our step, saying top and bottom. In this section, I'm saying, don't worry about the bottom. Don't do top and bottom. Just do left and right, only the top. Don't worry about the bottom. Why? How do you know which one to do? Well, because I have an equal sign. If you have an equal sign, then you have a left and a right. If I did not have an equal sign, if this was like a plus here, see how it doesn't take much visually, but that is meaningfully way different, actually. Now it's no longer an equation. It's no longer a left and a right. It's three things added up. And in that case, I would do top and bottom, like we did in the last section. I'm not going to do that and confuse you. But does everybody see the difference? That's what you'll have to recognize on the next exam. You have to say, does it have an equal sign? If it has an equal sign, then all of my thinking is left side, right side, not top, bottom. The left equals the right. Okay, so it's okay to only, because you might wonder, is that okay to only do the top, not the bottom? It is, because I'm doing the same thing to the left, all the terms on the left, as I am to the right, all the terms. I can multiply by 1,000,000 if I wanted to, right? The left equals the right. If I did it to the left and the right, if they were equal before and you treat them the same, they have to be equal afterwards, don't they? We all sense that truth, huh? All right, so now, what do we do from here? Yeah?
So, it's not like how it's not doing like the last one, right?
Say it again?
It's not going to be like for the last one.
Right. Last ones we did top and bottom.
Yeah.
Yeah, the difference is that equal sign. So none of my thinking is top, bottom. All of my thinking is left, right when you have an equal sign, because the left equals the right. Does that make sense? That's how you know whether you should be thinking top, bottom, or left, right. If you have an equal sign, you got a left and you got a right. If this was a plus, then it would not be true to say I have a left and a right. I don't have a left that's equal to a right. I can't do left and right. It'd be illegal to multiply by 40 in that case. You can't just be multiplying by 40 because you feel like it, or because you think, yeah, but that's the LCD. So what? You're not allowed to multiply only the top by 40, right? That would be crazy, right? But with an equal sign, you are, because the left equals the right. So it's okay to do. All right, enough said. I beat that horse to death. All right, so now what do? We cancel. Why are we even doing this? We want to cancel the denominators. 5 goes into 40 8 times. So 8 times 4 plus 8 goes into 40 5 times 1 times 5. Everybody seeing what's happening? See how all the denominators are canceling out? That's why this is easier. There'll be no more fractions. 20 goes into 40. How many times? 2 times. So it's 2 times q. Look at that. No more fractions. One step. They're gone. So what do we have? 32 plus 5 is 2q. 37 is 2q. Last step to get q alone. Divide by 2. 37 halves. So it's nice. It only took one page, huh? Remember the ones last time? We took a couple pages because of all the mess. So these will be easier because you get rid of the fractions on the first step. Does that make sense? We take out the fractions, don't we? Questions on that? How are we doing? Is that good? Does everybody see the difference? Top, top, top only. Because all my thinking is left, right, not top, bottom. And then just cancel, cancel, cancel. Multiply whatever's left over. Questions? Or should we try one? We good there? Try one? Okay. Yeah, let me help you with this one. So, again, it's an equal sign. Every problem in this section will have an equal sign. And what do we do when we have an equal sign? All of our thinking is left, right, not top, bottom. So, I'm just, you know what, really on this one, 5 and 49, they have nothing in common. Yeah. Really what we're just going to do is, you could do it. We want to go over here and do 5 and 49. Right? I'm not going to put the 245. Why don't I put the 245 in the box?
Because it has a 1.
Yeah, he's not under a bar. He's not a denominator. Right? I'm only putting denominators, things under the bar, in here. Okay. What goes into 5 and 49? Nothing. So then you just, there's nothing. So you just times them. They are the numbers. We are done there. There's just nothing to do. There's nothing that divides in it. Just multiply 5 times 49. Isn't it 245? Mm-hmm. So it is. So, which is kind of weird because there's a 245 on the right side. But don't worry. What are we supposed to do now? Am I going to do top and bottom? Left and right. Because I have an equal sign. So all my thinking is left and right. So 245. 245. 245. Is that good? So just the tops, not the bottom, because they're equal, left and right. Okay, and then let's cancel. So 5, use your calculator. 5 goes into 245, it's 49 times, huh? So that'll be 49, so that's 49x, and then 49 goes into 245 5 times, huh? 5x, and then that's a whopping number. I could do it in my head, but I hate to show off, so I'll let Claudia tell me the answer. 60025? Thank you. So there we go. You guys know, he's a white guy. That's the weirdest thing. All right, he's American. Anyway, so now it's easier, right? Now there's no more fractions. We get rid of fractions on the first step. So now we can do, what's 49x minus 5x? 44x. Last step to get x alone. What's that? Doesn't it? Yeah, just go ahead and divide. And yeah, probably will just stay like that. Yeah, I think it's just it, right? That's an ugly answer, isn't it? But I guess that's it. I'm going to go check. Okay, try that one. So multiply, again, we're going to go top, multiply through top, by the common denominator. And what is the common denominator there? All right. It's just y, huh? It's just simply y. Y is the only thing under a bar, huh? So y is the common denominator. So you're going to go multiply by y, multiply by y, multiply by y, huh? Let me let you take it from there. So going to cancel. That's the purpose, right, is to cancel. So 6 plus cancel. 4 is 5y. So that's 10 is 5y. Last step to get y alone. Just divide by that 5, right? And so y equals 2. Y equals 2. We good there? How many got that? Y equals 2? It's making sense. Good. Questions I can answer on that one. Starting to make sense? Just common denominator, top. All right, let's try another one. So number 4, 2 over... Yeah, I'm going to make that an x. 2 over x plus 8, 1 over x, 2 over x plus 8, 1 over x minus 7. X plus 8, 1 over x minus 7. Yeah. All right. So, so there we go. So there's number 4. Yeah, number 4, actually, there's a little bit easier way. So let me give you an easier way. When there's only 2 fractions, you can simply cross multiply. So when only 2 fractions can simply cross multiply. You know what I mean by cross? Yeah, we did it back with the slope problems. Remember those slope problems where we would go diagonal like that? Remember those kind? That's what I'm talking about. If you just have 2 fractions, you don't have to even think about LCD and all that stuff. When you only have 2 equal fractions, I should say, the equals is important. When you have 2 equal fractions, you can just go diagonal like we did on those slope problems, right? Remember those? That's how we handled those slope problems. So we get 2x minus 7, 1, x plus 8, like that. Good so far. And now, just go ahead and distribute. Like that and like that. So I get 2x minus 14, 1x plus 8. Okay, and what do we do? Are you good to here? What do we do now when we're trying to solve and we have x in 2 places like that? What do we do? Yeah, get x by itself by getting rid of one of those, huh? Right, when you have x on opposite sides like that, you basically have to just get rid of one of those two. It really doesn't matter which one. I usually get rid of the lower one, but either one's fine. So I'll go -1. That'll get rid of that guy, right? But whatever I do to one side of the wall, I have no choice but to do to the same thing to the other side. I got to keep the balance, don't I? Right? So then what is that? What does that leave me? 2x minus 1x is 1x. And this is 8. Last step to get x alone. Add 14. 1x is, what's that, 22? X is 22. And there we go. How we doing? We okay?
Yes, it's better.
We're much better, isn't it? 5.2 is awful. Yes. Yeah, we okay there? There'll only be like maybe 2 of those awful ones on the test. I mean, so just review that practice exam and you're good. Yeah, we'll talk about them again on practice exam day. I know many people are not feeling good about 5.2. We'll have one more shot on practice exam day. I'll definitely do a couple of those slowly with you again, and the 5.2 ones. And I think it's nice. It's nice when you see math a second time. For me, math science. Whenever I see the second look, it's like, oh, it's not so bad. I see. It's terrible at first. Me too. I see math science stuff. It's like, oh, what is that? And then I try it, and then like a week later, look at it again. It's like, oh, okay, not too bad. You just move the thing. And anyway, so maybe a second look will help. All right, let me hold on. Right here, remember I gave you a new rule. If you just have 2 fractions, you can just cross multiply. I want you to see that that's not really a new rule. It's just the same thing. What if we were to do it the other way? What would the other way be? Well, common denominator, right? Wasn't I saying you always need common denominator? Yeah, don't write this down. You don't need to do this. But I want to show you that my little cross multiply thing is nothing different than common denominator. Let me show you. If I was to do common denominator, what would the common denominator for those guys be? Well, both of them, right? You need all denominators, right? So what would I do? Top and top, right? So again, don't need to write this down. I just want to show you that it's not new what I'm doing. You would multiply by both of them, right? The whole, that's x minus 7. The whole thing top, and then right here, same thing, x plus 8, x minus 7, right? That's what you would do, because that's the common denominator, both of them, and top, the whole thing, right? Okay, right, that would be the other way. And then what would be your next step? Well, cancel. You'd cancel out this and this, and so what would you have left? Look. 2x plus, isn't that exactly what we did? And here you would cancel these guys out, and what would you have? 1 and x plus, isn't that exactly what we did? So I'm just saying cross multiply is the same result as common denominator when you just have 2 fractions. Now, if you had a third thing, if you had a plus 7 out here, some other third piece, no. Then you'd have to do the x plus 8, x minus 7, x plus 8, x plus 7, and you have to do another one here. You know, you'd have to do it the long way if you have 3 things. But with 2 things, just cross multiply, it's the same result. All right. Let's go to number 5. Okay, so yeah, so again, 2 fractions, right? Just do this short way. Diagonal, diagonal. Can you just do that same thing? Just cross multiply, diagonal, diagonal on that one. It's just 2 fractions. But you can see number 6, which is coming, we'll have to do the long way again, because that's got 3 fractions, doesn't it? So let's do number 5 right now. It'll be the short way. Diagonal, diagonal. Diagonal, diagonal like that, right? And just distribute. Kind of running out of room there. I'll bring it over x plus 6 over x. So diagonal, diagonal. So what do we do then? So we got to get x alone, right? When you have x on opposite sides, you get rid of the lower one usually, right? So subtract 5x from both sides gets rid of that one, right? And then we have 30 is x. Yeah, that's it. 1x, x, done. Because that's 1x, isn't it? Or just x. So we're done. We good? It's all easy. So the two fractions are easy. Just cross multiply. Now, let's go do number 6, which is harder. 80 over x. So I'll write number 6 here for you. 80 over x minus 80 over x minus 5 equals 4 over x. Okay. So we have 3 fractions, so we can't just cross multiply. What do we have to do? The long way. What's the long way? LCD. Yeah, then you got to do the whole LCD. Top, top, top. Right? Now, what is the LCD? Remember, that's the common denominator. That's one of everything. So, but only one. Remember, I did the shopping thing. You're shopping. You're going to go to shopping, and you're going to buy one of every type. So, one single x and one x minus 5 package. You don't need the other single x. You've already got one in your cart. Right? You're just buying one of every type. So here we go. X minus 5. And in the middle, x minus 5. And on the right, x minus 5. So all 3, right? The whole LCD, top, 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 x minus 5. Good. And then cross cancel. Cross cancel, multiply what's left over. Good. Okay. So yeah. So when we do this, we are canceling whatever matches, right? Whatever's the same top and bottom. So whatever's the same top and bottom. So right here it's x and x. Oops, is the same top and bottom, huh? So we cancel what matches, and then whatever's left over, meaning this stuff, whatever did not cancel out, we could just bring it down. So 80 and x minus 5. That making sense there? So far, so good. And then that minus in the middle, just bring him down. And then same thing on the next one. So what matches in the middle fraction? The x minus 5s. So they're totally gone. So they're just out of the picture. I mean, so they just divided, really. So they're just gone. They're like 7 over 7 cancels or something. You know, so they just are gone. And so what's left is just 80 and x. Is that good? And then here, they cancel. So when the same things, identical items, are under a bar and on the top, they cancel, don't they? And what's left over comes down. No more fractions, huh? So we always get rid of the fractions that way, don't we? Do you see why the common denominator gets rid of the fractions? The common denominator has one of everything, which is perfect to cancel out everything, all the denominators. Like that. That's his job in life, is to cancel out those denominators. So, all right. So I used to call him a hitman. I try to say weird things just to help people remember. You know, so I'm not up here doing the wah, wah, wah. I try to say a shocking word that'll stick with you. So, because what I would have in the past, I would have students that would forget to cancel. They'd do the good job, they'd write the common denominator up there, and then they would just bring everything down, including the x. Like, oh, no, he canceled. So he's not there anymore. So remember, that's his job. He's like a hitman. He takes out denominators, doesn't he? That's his job. Let him do his job. This guy takes that guy out. This guy takes that guy out. This guy takes that guy out, huh? So I guess they're a suicide hitman because they get taken out too. I don't know, whatever. The analogy breaks down, but whatever. Remember to cancel. That's the whole purpose, right? We don't like fractions. We want to get rid of fractions. We want to kill them. We want to take them out, don't we? So then we come down. This distributes. And this distributes. We good there? Just distributing there. She's calculated those bigger numbers. Okay, now this and this just cancel, huh? 80x minus 80x is 0. So we just have minus 400 is 4x minus 20. Everybody good to there? And now x wants to be alone, so what do we do? X is down and saying, I want to be alone. Get rid of all that stuff. Get rid of this 4 and this minus 20 so that I can be alone. X is a big loner. So add 20 to both sides. So 4x is, what's that, minus 380. And last step is, oops, just scribble all over your paper. Divide by 4. And would you all say that answer is? 95? Okay, thank you. Negative 95. How are we doing? Is that okay? Questions I can answer on that one? Is that good? Because that's the heartbeat of this section. Is common denominator, which means one of everything. Top, top, top. Cancel, cancel, cancel. Bring down what's left over. That's how we get rid of fractions. That's how we handle fractions. So there we go. So the first step here, see how that middle denominator needs to be factored? This guy right here, that needs to be, the two parentheses. So let's do that first. So the other parts I'm just going to rewrite. X over x minus 4, that doesn't change. But in the middle, how are we going to do two parentheses for that x squared minus 16? Let me let you do that first. So how do we factor x squared minus 16? Plus 4 minus 4, huh? Because positive 4 times minus 4 would be minus 16. We good there? Everybody good there? So now, can you do exactly what we did in the last problem? So now it's just like the last problem at this point, huh? Just find the common denominator and put the whole common denominator top, top, top. And what's the common denominator? One of each piece. So you see what it is? It's going to be 1, it doesn't matter what order, 1x minus 4 and 1x plus 4. In the left, 1x minus 4, 1x plus 4 in the middle. 1x minus 4, 1x plus 4 in the right, huh? Left, middle, right, the whole common denominator. So this cancels that. We good there? And then just bring down what's left over. And then in the middle, both of them cancel, huh? And just bring down the x. And then in the right, the x plus 4's cancel. Bring down x plus 5, x minus 4. There's the equal sign, the wall, the left side, right side. We good to there? You take it from there now? So go ahead and multiply it out. You're going to end up with x squared on both sides, huh? And you can just cancel that x squared from both sides. Subtract x squared from both sides. That x squared will drop out. Give you another minute. Okay, so I'm going to distribute x times x, x squared plus 4x. Over here, x squared, kind of scribbly here, squared minus 4x plus 5x minus 20. Good to there. And then 4x and x. Yeah, that's 4x and 1x. That's 5x. Minus 4x plus 5x is plus 1x. We good to there? Now, notice how we have the exact same amount of x squared on both sides. Rather than like 3x squared and 7x squared, different amounts or something. We just have 1x squared on both sides. So that means it's going to drop out because we'll just subtract x squared from both sides, right? You can always do the same thing to both sides, and they're gone. And so we just have 5x is 1x minus 20. I'll go to a new page and finish that. But does everybody see that step there where I just subtracted the x squared from both sides? And it just canceled out. So now we keep going, so I'll bring it to a new screen. So 5x equals x minus 20, so we have 5x is 1x minus 20. Right, everybody good to there? Questions to there? Yeah.
Where did the 5x come from?
Oh, good question. 4x and 1x made the 5. Yeah, remember when you're adding x's, you just add the numbers in the front. It doesn't become x squared. But when you times them, x times x, that's when you get x squared. If you're adding, you just add the numbers in the front. If you're multiplying, you add powers, don't you? Everybody remember all those differences? Good. Other questions I can answer? And then right here, right, minus 4 plus 5, together those make plus 1, don't they? 5 minus 4 is plus 1. All right, and then now at this point, what do you do? Again, you have x on opposite sides. So just get rid of the lower one, huh? So subtract 1x. Boom. From both sides, and we get 5x minus 1x. 4x. Bring down the minus 20. Last step to get x alone. Divide by 4. X is minus 5. And there we go. X is minus 5. How we doing? No questions? All right. Let's try that one. So the first step is to do what? What needs to be done with this denominator here? He's got to be factored, huh? First step in factoring him, remember, is GCF. First take out what's in common there. So if we take out a 4, we have x squared minus 9. Is that good so far? Does that make sense? And then that x squared minus 9, and I'll just rewrite the other parts. What can I do with this x squared minus 9? X plus 3, x minus 3, right? So it'll end up becoming 4. X plus 3, x minus 3. We're all good with that factoring there? Does that make sense what I did? So you always do GCF first, right? That was the exam we just had, was factoring. First do the GCF, take out what's in common, the 4, and then factor the rest. So there it is, factored. Now take it from here. Right, so maybe I'll rewrite it. So here, let me write it 1 over 4x plus 3, x minus 3. All right, so I'm going to rewrite it 1 over 4x plus 3, x minus 3. Plus 1 over x minus 3 equals 5 over x plus 3. Okay, so I'm going to multiply through by the common number, which is 4, x plus 3, x minus 3 in the left, and 4, x plus 3, x minus 3 in the middle, and 4, x plus 3, x minus 3 in the right, right? The whole common denominator, top, top, top. This making sense? Getting the hang of this? So that's kind of the same thing every time. And then we cancel. Whatever matches. The whole thing matches, and we just bring down a 1 for the left fraction. Right? And then in the middle, whoop, I canceled the wrong one. It's this one, huh? I messed up there. The x plus 3, the 4, and the x plus 3 are all that remain. We good there? There was a 1 there, but a 1, multiplying by 1 doesn't do anything. And then on the right side, x plus 3 cancels. So what's left? 5 times 4, 20, x minus 3. Everybody see that? These guys come down to be 20, 5 times 4. How are we doing? We good to there? All right, keep going. So then this distributes. Distribute 20x minus 60. Okay.
4x plus 13.
Did I do something bad? Oh yeah, right. So these will combine. 4x plus 13, right. I just combine those, just add those up. Get down to here. We have x's on opposite sides. Again, don't worry about the 13 and the 60 right now. First, do the x's. What do you do with the x's?
Subtract the 4x.
Get rid of the lower one. Yeah. Subtract the 4x from both sides. Is that good? And this will be 16x minus 60 is 13. And now x is over there on the right saying, I want to be alone. Get rid of this 16. Get rid of this minus 60 so I can be alone. So we add 60 to both. Cancels. 16x is what? 73. Last step. Divide by 16. Divide by 16. So x is 73/16. That's a kind of ugly answer. Did you get it, but thought you maybe had something wrong because it's so ugly? Now, I know I'm going to have to kind of move fast. I just looked ahead. The next section's word problems. I don't want to shortchange you on those word problems. So I'm going to start moving, so I know I'm going to go faster than everybody's able to understand. That happened to me more than half the time sitting in math and science lectures. So let me encourage you, though. That's why we have the YouTube. You can go back over this later. I had to just look over my notes back in 25, 27, or 30 years ago when I was a student. I just copy it all down and then look it over later. So I'm going to have to accelerate at this point because I want to get a few down for you. But go back over YouTube. When you're doing the homework and you get stuck, go back over, play them again, watch them, watch the steps, slow it down, stop it, all that you need to do. So first step, all those denominators need to be factored, huh? Got to factor all those denominators. Can you do that? Yeah, this is going to be a hard one. So I'm just going to kind of go quick because I need to keep things moving. So how do you factor 5x minus 30? What's the first step whenever you factor? Yeah, take out what's in common, huh? So what's in common there is 5. And then in the middle, what two numbers? So it's going to be 2. In the middle, it's 3 terms. That becomes the 2 parentheses. What two numbers multiply to be 36, add to be minus 12? -6, -6. So, and then over here, take out a 6. Good. Everybody good there? So I factored all those denominators. Yeah, we always begin by factoring those denominators. Now, when we have identical twins, same thing twice here. You know what we do with that, right? We make it squared. Okay. All right, so now, what are we going to do? We're going to do the common denominator, top, top, top. How do you do the common denominator? You shop. Remember the shopping plan? Take one of each. Now, we've got a solo 5 and a solo 6. That's different than 5 glued to an X or 6. You know, those the solo guys first. So you got the 5 and the 6. What? Multiply them, right? 30. So 30. Everybody's good. If you put 5 and 6 in a box, so then the out front numbers, we box them. Nothing goes into 5 and 6. You times them. It's 30. You with me on the number part? So there's two different things going on here. There's the number part of the LCD and the letter part. So the out front numbers, you just times them, don't you? 5 times 6, 30. Now when it comes to the letter part, letter packages, you take one of every variety, one of every type, but the biggest one. Remember, you're going to Costco and you say, I'm going to buy the most expensive toothpaste and the most expensive milk and whatever, right? But you're buying one of it. So I'm going to take 30, and now what else? There's an x minus 6, an x minus 6 squared, and an x minus 6. They're all the same thing. Which one do I take? The biggest one, the most expensive one, the squared. You don't add them all up and say fourth power. We're just taking the one biggest one, not all of them in our cart. We're not throwing all the toothpastes in the cart. We're just buying the one most expensive one. Does that make sense? So that's the common denominator. 30 and x minus 6 squared. Why? Because 5 and 6 go into 30. Right? I took the numbers and I boxed them and I multiplied them. 5 times 6 is 30. And then as far as the letter packages go, you take the big one of every type. There's only one type up there. And you take the highest power. All right, and then you put that whole thing in the left. 30 x minus 6 squared in the middle. 30 x minus 6 squared in the right. Left, middle, right. The whole LCD. Top, top, top. Same thing. Cancel what matches. Okay, now be careful here. It's where you want to be really, really clear. So you want to show what cancels and what's left. This is where I encourage you, sometimes I'll work with students and they're writing really tiny. You can hardly see what's there and what's going. You know, I'm a pretty sloppy writer myself. But I don't make a lot of mistakes because I usually make things big. Just making them big can help. You know, make them big. So 5 goes into 30. Notice I cancel them. I actually do that. Don't just eyeball them and think in your head. Show them canceling. 5 goes into 30 6 times. So notice the 5 and the 30 are bye-bye. They're gone. But the 6 remains. And this x minus 6 cancels and leaves the first power, right? There was squared, x minus 6 squared. The one in the bottom canceled one of the x minus 6s. Because that really means 2 x minus 6s, right? One of them canceled. So what's left over here? 6 and x minus 6. Let me pause there for a minute. Everybody see what happened on that left fraction? 5 went into 36 times, and the x minus 6 on the bottom canceled one of the x minus 6s on the top. So what's left over is a 6, an x, and an x minus 6. Can you do the middle? Do the middle fraction. Cancel what you can, bring down what's left over. Let's cancel, right? And 6 times, these are all multiplied, aren't they? 6 times 30, 180. Is that good? Or you can just bring down 6 times 30 and make it 180 on the next one. Line, whatever. Everybody see that? Yeah, maybe I can go slower. I can just bring down 6 times 30. That'll be 180. All right, and then over here, 6 goes into 30 5 times. And x minus 6 cancels one of these x minus 6s. This one's a mess. What are we left with? 5, x minus 5, x minus 6. Do you see what happened on that right fraction? 5x minus 5x minus 6 is left over after the cancel. So everybody see I divided 6 into 30 5 times. And the x minus 6 on the bottom canceled one of the x minus 6 on top, leaving one left over. Left over the 5 and x minus 5, x minus 6. Okay. So now we just got to multiply all this stuff out. So boom and boom. 6x squared minus 36x. Here minus 180. Over here, this one's a big pain. You got to FOIL out the x squared, x minus 5, x minus 6 for stuff. Boom, boom. X squared minus 6x. And then boom, boom. Minus 5x. Plus 30. Gather like terms. Minus 6x minus 5x is minus 11x. Yeah, this is a long and difficult problem. Good to there. I'm going to go to a fresh screen. If you're okay with that, everybody caught up with that? That making sense? I'll come back. So 6x squared, what is it? Minus 36x. Minus 180 is 5. Parentheses x squared minus 11x plus 30. Everybody good to there? So now we've got to distribute through that right side. We see how the gathered like terms here. Now distribute through the right side. Boom, boom, boom. 5x squared minus 55x plus 150. This is a very challenging problem. What in the world are we supposed to do now? Is this thing getting better or worse?
Worse.
There seems like it, huh? Everybody good to there? So it'll be on YouTube if you missed something. All right, I better move it. So you need to have a game plan in your mind when you see x squared. I've mentioned it a couple times, but I know I talk at you 5 hours a week and say lots of things. But does anybody remember when you see x squared, when you see x squared with an equal sign, there's a certain plan. Step number 1. Anybody? I think I've said it in here. Maybe I'm confusing them with some other side. Get a 0. Whenever you see x squared with an equal sign, you got to get a 0. We said that? I think that was on our last. Anyway, so So if x squared is hanging around, which it is, we had x squared a minute ago, but it dropped out. This x squared is not dropping out. There's a different amount of x squared on the two sides. It's not dropping out. So when you see x squared with an equal sign, step 1, get a 0. Step 2, factor, meaning like 2 parentheses. Step 3, each equals 0, and solve. So there's the game plan. You want to know that like the back of your hand. Somebody wakes you up in the middle of the night, says x squared with an equal sign. You want to go get a 0. You want to just know it, just because it's going to come up all the time throughout the rest of this course. The next 7, 8, what do we got? 7, 8 weeks. We're going to 2 months. We're going to just keep doing it again and again. Question?
What did that say? Solve?
Solve. Yeah, just solve. Each one equals 0 and solve. Right. All right, so I got to get a 0, right? Step number 1, when you see x squared and an equal sign, right? You understand this isn't just x to the first power, right? Right? You track with me. Look back at last one we did. See down here, we just had x to the first power. You know, no big deal. Just solve for x. It's just regular x, no big deal. But x squared, little bigger deal. So what do you do when you see x squared? You get a 0. Well, how do I get a 0? Well, that means you make one of the sides, poof, vanish. Right? If you're going to get a 0, you got to get rid of one of the sides entirely, don't you? which means you got to do the opposite. Now, which side has the lower x squared? The right side, right? 5x squared is lower than 6x squared. So I just go to the lower x squared side and I wipe it. I get rid of everything over there. So I'm going to go minus 5x squared plus, see I'm doing opposite, opposite, and opposite by 0. Everybody see what I did over there? I did opposite, opposite, opposite. Gone, 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 0. I got a 0 on one side. But whatever you do to one side, you have no choice but to do the same thing to the other to keep the balance, right? If two things are equal, you treat them the same, they'll be equal after. So I've also got to go minus 5x squared plus 55x minus 150 on the other side. And let the chips fall where they may. So on the other side, I get 1x squared plus something I don't know, 19? 19x minus 330. It's ugly. So I did step 1. I got a 0. Step 2, factor. Factor. Right? Step 2, factor with the parentheses. So that means you're going to do the double parenthesis, right? X is in the front. You need two numbers that multiply to be 330 and add to be 19. So I would use my calculator at this point. It's a big number. I don't know right now off the top of my head. I would take the 330 and I would divide by 2, divide by 3. You're looking for two numbers that can make 19. Divide by 2, you get 150 and 165. No way is that it. Divide by 3, you get 110. That's not even close. I'm going to go to bigger numbers. Divide by 10, 33. No. Divide by 11. Is it 30? That's it. Bingo. Why bingo? Because if you subtract 30 minus 11, you get 19. You get that middle. There it is. When we say add in the middle, we mean add or subtract, right? If you add a negative, it's subtraction. So there's my pair. See what I did? So you just grab the big old number at the back, the 330. Don't worry about the negative. Just grab normal 330. Just use your calculator. Divide by 2, 3, 4, 5, 6, 7, 8, 9. And until you find a pair of numbers that can also add or subtract to be the middle. I found when I got down to 11, divide by 11, 11 and 30. Yeah, that can do 19. That must be it. So 11 and 30. Now, remember the sign in the middle goes on the bigger. Plus 30 minus 11 makes plus 19 in the middle. So there's step 2. Factor with the parentheses. Good to there. Step 3. Each part gets its own 0. So x minus 11 is 0. X plus 30. You remember that, right? Because the two things times to be 0. Either one could be 0 to make them times to be 0. So you get two separate equal zeros. And then, it's just going to be opposite signs. Remember, we've done this before. Get plus 11 minus 30. Those are both answers, I think, right? Yeah, they're both good answers. So how do you give the final answer? Just want both answers with a comma. Either order. Plus 11 minus 30. There it is. Questions on this one? That good? That's terrible. That's what that is, huh? So there's two choices that stand before you. You can try that. So this would be one. When you get to the homework on Math Excel, what number was this? Number 9. You should do this one. You should look back at the YouTube. Make sure you really master it to get through that number 9. Or the other choice is I got time for this. I'm just going to skip it. Well, then, that's how you make it through a math science classes. You got to spend the time. So it's all there on YouTube. You can do it, but it's going to take a long time of rewriting and rewriting. Get to where you can write it out on a blank piece of paper and do all that yourself. That'll take several tries. Like what I would do all the time, hard problems like this, I would try it on my own. I'd write it on top of paper and I'd try, and I get stuck, and I go back to the notes, go, oh yeah, and then I try it again, and back and forth until I could do it top to bottom all by myself. That's hours and hours and hours. That's what it takes. A lot of people are not willing to do that. Okay, so we better, remember the first thing is always factor any denominators that need to be factored. Do any of those denominators need to be factored? Yeah, the y squared plus 2y, huh? So that needs to be factored first off. So I'm going to do that. Take out, that's just take out a y, isn't it? GCF, take out what's in common, take out a y. We good there? Now, now we do common denominator, right? Common denominator, top. There's 4 terms here. This is the first one we've had 4. Anyway, what is the common denominator? Can you do that real quick? Shop the common denominator. Here's your first dial. Here's your second dial. Here's your third. What about the 6? Is he under a bar? No. So ignore him. He's not a denominator, is he? That 6 is not a denominator. So we don't shop him. We only shop denominators. So go through the denominators, the aisles of the store, and take one of every item and throw it in your cart. Just one of every type of item. So we're going to have a y plus 2 package, a solo y, which is different than a y plus 2 glued package. Remember, pluses glue things? Right? And then that's it. And then this is just the same stuff again. So y and y plus 2, right? What do we do with it? Top. Y plus 2 in the left. Y plus 2 on the second term. Y plus 2 on the 6. Don't forget about 6. He's like, I'm a term too. And y plus 2 in the right. Right? We good? Even the 6 there. That's the main part I wanted to show you. Even the 6 needs a y and a y plus 2. And now what do we do from here? Cancel. Cancel top and bottom. Bring down whatever's left over. So y plus 2, y plus 2. So y times 4y. Y cancels y. 8 times y plus 2. 6y, y plus 2 equals, these guys cancel, 16. Can everybody see what I did there? Is that making sense? With what I did? See how with the 6, it just all comes down. Nothing cancels with the 6 because there's no denominators. Right? It's only stuff under the bar that cancels with stuff at the top. The 6 has nothing under the bar, so it just all comes down. Right? Nothing cancels with the 6. Right? Everybody see that? And then I'm going to multiply y. Now, careful, that's a y times 4y, isn't it? So that's 4y squared. And the 8 distributes 8y plus 16. Now the 6y distributes 6y squared plus 12y. See all that mess? Gather like terms, right? 4y squared and 6y squared? 10y squared. 8y and 12y? 20y, right? We don't make a y squared, just 20y. Just have the numbers in the front, right? Plus 16 equals 16. What are we supposed to do now? I'm looking at y squared with an equal sign. Get a 0, right? Somebody wakes you up in the middle of the night. Y squared with an equal sign, get a 0. When y squared with an equal sign, get a 0. So that means subtract 16, right? Get a 0 on the right side. So we okay to there? Can I go to a new screen? And then factor. So 10y squared plus 20y. Right, yeah. Okay, so now, yeah, so when you got y squared with an equal sign, step 1, get a 0. So gonzo 0. There we go. These cancel. We good to there? Step 2, factor. How do you factor 10y squared plus 20y? Take out what's in common. What's in common? 10 and y. Good. 10y. One parenthesis. It's not the two parentheses because it doesn't have three terms, right? Just have two terms. Take out what's in common. Take out 10y. Leaves y plus 2, right? Factor, and then step 3, each part gets a 0 and solve. So the 10y alone gets a 0, and the y plus 2 gets a 0. Each part, because they're times to equal 0. If two things are timesing to equal 0, either part could be 0, huh? Remember all that? And now we solve each one. How do we solve 10y equals 0? How do you get rid of that 10? Can I subtract 10? No, because it's times, huh? It's 10 times y. So opposite of times is divide, right? So then y is, what's 0 over 10? Just 0. Move that over. Negative 2. 0 or negative 2. Oh. Yeah, guys and gals, after all that, the answer to this problem is no solution. Yes. Why? I'm not going to put this on the test. I promise. This is a weird one. I just realized there's this one special extra rule, and I'm not going to test you on it. So you can just make a note right now on your paper. Question number 11 in your homework will be no solution. You can save some time. Question number 11, no solution. Now, why? Why is it no solution? Well, basically, these answers are bad. Why are they bad? Well, you're a bad answer. Why? Why is he bad? Well, because he makes the original, both of them make the original denominators. Remember the bottom fraction can never be 0? Take that 0. Go back here. If you put in 0 right there, that denominator is 0. Now, if you put in 0 there, that one's not 0, right? But what's the other answer? Negative 2. You see, if you put in negative 2 there, negative 2 plus 2, that one's 0. So they're both bad because they make different denominators 0. So they're actually both bad. And now, don't worry about that. That's just a little too much. So I'm not going to push you that hard in the test. I won't give you ones where you have to worry about that and check for that. But make a note in your homework, number 11 is no solution. After all that terrible work, no solution. But hopefully it was beneficial work about all these different rules. We good there? Questions?